I will join you as already stated. We will have a discussion and see what kind of balancing among the three of you seems to be optimal for optimal sustainability. And we would like to start with Sven in that kind of order of recycling, reusing, repairing. So Sven is going to make the case for the recycling part.
All right, thank you very much. Hello, everybody. Thanks for having me here and giving me the challenge of talking about recycling and sustainability in 8 minutes. Well, let me start. And why recycling is a must-have. I think this picture illustrates very nicely. We want to extract materials from our urban mine, so we don't need to exploit materials from primary mines, because this has a number of significant advantages. The secondary materials have a lower CO2 footprint, up to 96%. They are much higher concentrated, and they are already in use, so we don't need to exploit new ones. And if that is not convincing enough, the Global Battery Alliance is currently working on more sustainability rule books to come, about 20, where to all of those recycling will massively contribute. So that is a bit of the why recycling is very important. But okay, let's face it, and we've heard it already this morning, there's a number of challenges that recycling and sustainability will have to deal with in the EU. First of all, EHS compliance. Battery itself is a small chemical factory. The EU has the strictest laws in place globally. And if we want to comply with all these environmental, health and safety standards, we have to undertake a lot of efforts to do that. Second, logistics red tape. There is a lot of, let's say, different understanding within the EU member states of what a waste is, what a product is, when it is end of waste, when it is hazardous or not. And even within member states like Germany, in all the federal states, we have different regulations, different understandings and definitions. Material availability, another challenge. About 60 to 70% of battery scraps, mainly in the form of black mass and related products, are leaving the EU. So that is our raw material that we're leaving. So if we want to have critical materials stay here, we need to do something about it. Then information gaps. If we get a battery back as a recycler, a lot of data are missing. So it's not clear what we have in front of us when we are supposed to recycle it in a sustainable way. Accurate compositions, dismantling information, adhesives types, and so forth. So it's very difficult to optimize processes. Then technology readiness. Of course, a lot of things are in development and under development, and a lot of things are still being done manually, especially in the preparation phase. In the refining phase, we have the challenge of lithium refinery with high yields and robust processes. So there, a lot of pilot-scale industrial operations are running currently. And finally, we have asymmetric investment, an over-investment in pre-treatment and an under-investment in refining. So what can we do about it? So there's a number of domains of attention, but first of all, it is very important to say that we need to talk about high-quality recycling. High-quality recycling, and I've given you the definition how we see it. It needs to be economically viable recovery of many relevant ingredients in marketable quality, high yields, and under highest ESG standards. So the criteria are working in closed loops, in application-ready outputs, so intermediates are no end of waste, and we need to base our, let's say, efforts and benefits on life cycle assessment in a scientific way to really come up with high-quality recycling. That's how we do it. And then a number of domains that help or that are under attention. First, I should have maybe not said individual, but smarter regulation. We've heard about the battery regulation this morning. It's a very good example, being a bit of a role model, as it reflects life cycle stages. For the first time, a regulation is doing that, a comprehensive, systematic approach. It has specific recycling indicators. It focuses on design for circularity, and it makes transparency and collection targets mandatory. There is a secondary legislation process going to be lasting for more than 10 years, where the evolution of technology and context is being reflected as we then define methodology, allocation methods, and thresholds for indicators like recycling efficiency, recycled content, material recovery targets. So reflecting what is happening in the meantime. So that is certainly also a very good approach to building legislation. And then finally, we need to have a good regulatory landscape, meaning we need a contextual alignment of these regulations. So battery regulation alone will not do the job. It needs to be aligned with waste shipment regulations, both for intra and extra-EU shipments, with the eco-design for sustainable products regulation. That is a lot dealing with product design. As we know, 80% of an environmental footprint come from the design phase for product. For instance, also the end-of-life vehicle directive revision, which is currently proposed. All of that needs to be aligned. Then digitalization will certainly help a lot, and we've heard about battery parts earlier this morning. I'm very happy that we as Umicore are part of the EU Battery Parts Consortium that is funded by the German Ministry of Economy and Climate Action. And it's really amazing which potential use cases the battery pass itself holds. The DPP data giving us the opportunity to really do more informed decisions, so going from an intuitive to more professional decision making, and the battery pass system really connecting all the relevant stakeholders that need to work together. Traceability up and downstream, so also end-of-life traceability will be a point of attention. Data quality, integrity, availability, where we haven't had data before. So that's certainly going to be a big game changer. Lots of challenges also here, like interoperability, so that all these different systems that are operated will be able to communicate, talk to each other, open standard, open source, scalable, so data exchange systems, but that is certainly something where recycling will benefit a lot. Then technology itself, we have to be technology open. There is no one-fits-all solution in recycling for all these different batteries coming up and being developed, all these different battery chemistries. There is pros and cons with all the process settings. We need both the generalist approaches where we have a very, let's say, tolerant input for batteries, also versus more specialized recycling routines where people, for instance, go for lithium recycling as a specialty or as a specialized operation. Technology will also have the challenge to really catch up with the rapid evolutions that are currently ongoing, which we have seen earlier this morning. Collaboration, I think that's also a key area of attention. We need to be aware that certainly we should or we must avoid competition of our strategies. And recycling must also not be a self-purpose. So if we as a recycler just try to recycle as much as we can, this is also not going to contribute to sustainability. We need life cycle management, both physically and intellectually. So we need to have the material streams close, but we also need to intellectually put our heads together in order to have the best possible solution in a continuous way. And we need to complement our competencies. No one of us will be able to do all of that on their own and alone, so it has to be in a multi-stakeholder approach. And then finally, the famous level playing field. But here, I think one of the aspects is that we need to be as participants in such an ecosystem, not only need to look at our own benefits, but we always need to look at what is the benefit for the ecosystem. So we need to do both. And that is certainly a bit of a change compared with how we have worked in the past. Equivalent conditions when we do stuff elsewhere, so then we need to be very precise in what we mean with equivalent conditions, so proper definitions we will need here. Local for local supply chains need to be built up. I understand a level playing field as a more value rather than a quantity-driven economy. Finally, de-risking of investments. Last slide. So what I think what we have in front of us, or which we are already part of, is a massive change process. And massive change will not be solved by technology, it will be solved by our minds. So that I think mindset is really the key here. And that's why I think a holistic system consideration needs to open up new perspectives. It should be more and less or. Also, the title of this session should maybe read recycling, reuse, and repair, and not or. Then multi-stakeholder approaches, I mentioned that already, to establish level playing fields, so partnership should become the new leadership, breaking a bit the silo mentality, which we have worked in the past. Recycling needs to become an integral part of product design. We need to start with the end in mind, and that is very important, and consider value circles rather than value chains, and really consider recycling as a high-tech activity and not a scrap dealing activity. So last point, circularity needs to complete sustainability always for end-of-life collection, so that we kind of connect B2B and B2C, where we usually have a bit of a break when it comes to collecting back materials, and ideally we can turn consumers somehow into users in the future. Yeah, thank you very much. That is my only Umicore-specific slide, circular materials for a better life. Thank you very much.
Thank you very much, Sven. We hand over to Nuria, who is going to make the case for the reuse.
Actually, I'm picking it where my co-panelist left it, and I'm very glad to see your last slide. And if somebody was expecting here a fight between the recycler and the repurposer who takes the battery, that's not what it is, right? I mean, we also see this ecosystem, and we see each other more on the and than on the or, right? So it's everything together. I'm going to start with some questions. I'm not trying to take the head of the moderator, but I would like to show you through those questions how dynamic and how changing this market is, and how this poses a huge challenge, especially for small companies like mine. Here you can see, just one last point, sorry. As second life remanufacturers, we need to keep an eye on what is coming to us, so which batteries are reaching end of life from the electric mobility industry. But we also need to keep an eye on the battery market, because we do not compete with second life manufacturers, we compete with batteries in general, also first life batteries, and that's one key thing. So we need to monitor both sides of the market to make sure we are dealing properly both what is coming to us and what is coming out of us. And this is what I'm trying to show in this slide, like e-mobility. So we have listened many times already today how the battery market, the lithium-ion battery market is increasing a lot in the next years. And I just would like to point out here that the electric mobility market segment is retaining up to 85% of all the lithium-ion batteries that are going to reach the market in the next years. That means, and that's my first question, what's happening with the other market segments that also need lithium-ion batteries? Will they have enough batteries for them if there is this discussed shortage in lithium-ion batteries? Will this challenge be solved with another technologies, as we saw this morning already, maybe another chemistry, maybe another type of batteries? So how we make sure the energy transition, and not only the the transition to electric mobility is secure, and there is enough material for all of them. Is this possible shortage turning into an increase of prices for certain market segments? As I said, I don't have answers to many of those questions. I'm just here posing them just that you understand what are our, let's say, daily challenges. The second point, and here I'm going to speak a bit of recycling with your permit, the chemistry that it's used inside the lithium-ion batteries is changing lastly, and as we saw this morning, it's moving towards LFP. LFP poses a huge challenge to recyclers because there are not these expensive and very relevant materials inside the batteries. There's no nickel, there's no cobalt. Of course, there's still lithium, there's still graphite, but the recycling process is more challenging. So what's happening to those batteries when they reach end of life? What do we do with them? Do we recycle them? And again, here my question, what's coming? Maybe we see that the market splits into two different flows, the flow of low-value battery chemistry, and those are radically reused, or the other market flow, which is NMC batteries or high content in cobalt and nickel, which has a huge value for recyclers, and they go straight away to recyclers. Is this crucial also for Europe? Because we need to secure enough raw materials, as we listened this morning. So maybe this is even a strategy that could help towards having sovereignty into the battery value chain. We have also heard today about the prices for batteries, so for first life or new batteries, as we call them. Last year was the first time that the battery pack price increased, but this was due to a very specific context, as we know, due to geopolitics. This year, in September, the batteries went for the first time down from the $100 per kilowatt hour milestone that we have set it. But then just 1 month after, China sent a warning to the world, like, maybe you are not getting graphite, right? So is this turning again into an increase of prices or not? In general, what we see is a high volatile market with a lot of regulations and a lot of changes responding to those regulations as well. Also, as we listened this morning, we saw that the sodium batteries came as a response to the increase in the lithium-ion battery market. So how are we going to secure that the price of ferrous life is staying down and that we have enough materials to manufacture them in Europe? And I come to the last slide on questions, which is the prices for second life. There is nothing set. There's no regulation, there's no standards, there's no laws on how you regulate the prices for second life batteries. And even if you look at the plot on the right-hand side, you see that sometimes second life batteries can be even more expensive than first life batteries. So what's the point here? We really need to establish a fair and a science-based price for second life batteries. It's not only about the SOH, it's much complicated. We need to take into account other parameters like availability. How much volume can I get of those batteries? What is the chemistry? So those are a lot of questions. As I said, we are asking ourselves every day. So let me go very fast into presenting how Betteries, a small company, a pioneer in the second life market that was founded in 2018, with the mission of bringing second life batteries to a market that was still not addressed, which is the off-grid market segment. Any activity that is happening off-grid, so construction, filming industry, disaster relief sector still relies on fuel-based generators, and they represent a huge burden, specifically in emerging economies. So we were founded in 2018 with the aim of bridging the huge volume of batteries that was coming out of the electric vehicle industry and moving that volume towards these kind of off-grid applications. Since then, we have developed several systems based on two specific purposes. The first one is reaching economy of scale by serial production, and we did that by developing a system that is modular and multi-purpose, which means we just manufacture one product that can be used for different purposes. The second one was key to secure enough volume of batteries, and for this we reached an early enough partnership with the French manufacturer Renault, and with this we have secured enough volume of batteries for the next years. Data, 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 data. We have listened today a lot of times about data. Data is crucial. This is why our batteries are also connected devices. We monitor them, we control them. Safety is a key point in batteries, and if it's a key point in batteries, in new ones, for second life is one of the huge barriers we need to overcome. And the last slide, I just would like to highlight what are our learnings to date, and there are three main learnings. The first one, we must be flexible. We must be able to incorporate into our system almost any battery coming out of an electric vehicle. Almost every electric vehicle has a different battery in terms of geometry coming to us, so that's a huge challenge. The second one, strong partnerships. We really need to work together to develop a sustainable battery value chain that is also economically profitable. And the last one is data, as I said, connectivity in terms of monitoring, but also in terms of traceability. And with this, my time is over. Thank you very much.
Thank you, Nuria. And then we directly pass the floor to Christoph, who is making the case for repair.
Many thanks, to each and everybody. I would like, to start with one question. Who is driving here as his first car, a car 10 years or older? I don't see many of you here. Now, if I ask your students, maybe 50%, if they have a car, maybe not in Berlin, but outside of Berlin, 50 or 60%, maybe. Therefore, for us, and that's what we see, and I'm coming from a company whose focus and background are facility services, engineering services, automation services, and also maintenance services, logistics services in factories. Greenfield plants, we heard a couple of them this morning, also brownfield plants. And you see, now the question is, you see, for us, you see, when we follow and support the transformation of the automotive industry from combustion to EVs, what will happen there? You see, what will be the future? Yeah? We heard this so far, we can recycle, and at the end, there's always recycling. See? Then we can reuse, and we heard it here, reuse, but I would say the first thing is to think about this, can we repair batteries? Yeah? Maybe not in the beginning, you see, the first 2 years, that's maybe warranty, also repair. But then later, you see, when the car is getting older and older, you see, and not only the car, I come to this also in other areas where we see the question is, can we do this? And we see here and recognize currently an increasing interest of our customers in the circular solutions, yeah? Especially for batteries. What we also see now, you see, and that's happened the last 1 year, a ramp up in requests. A ramp up also, you see, in pilot installations, a ramp up also in orders that we get. The global car manufacturers, also other global players, I show this in a minute, and also, you see, investors show more and more interest in the question, can we repair this? Can we not only, you see, recycle it or bring it in a reuse? We have developed now by ourselves, this in the last, I would say, 4 or 5 years, since this ramped up experience. I show this, and mostly we have done this here in the Saxony area. But one key question, that's for me, and maybe that's also for the discussion, where will the batteries come and when will the batteries come? There is, we all know, currently a battle for NO car batteries. There are not enough NO car batteries that everybody can participate and grow in this market. We see, and when we think a little bit about this, what does this mean? You see, what kind of services are requested? And what is the current situation? On the one side, the first thing is the logistics. You have to bring the batteries somewhere, on the car by itself, or you see the battery as a system itself. See, you see it here, see on the left side. And the key question is, can you store a battery? Can you store a battery in a typical logistics hall? No. So you need special licenses, you need special applications, it's a question of insurance, it's a question of the government. It takes time. This takes really a lot of time, and we heard this morning also. It's different by state, by city even, and by country, and this is what I see one challenge that we have to overcome. Another one is people. See, we have 22,000 people, but we had in the beginning nobody who was really specialist in this, and we had nobody there in the beginning who had the licenses, especially working with under 800 voltage and all these things. We had to train people. We had to find also ways how to train and qualify them, not only training, and that's that we see. And the third thing is how to do repair. Yes, we got from the supplier, from the OEMs, and also some cell manufacturers, we got drafts what to do. But what does it mean? You see, how many faults are there in a battery if you want to repair them? We have currently in our database 230. Is 230, are this all? Are this 80%? We don't know. We find nearly daily other possibilities, but overall, and that's what I can say, the number of parts that are normally have a failure are limited. Absolutely limited, you see. Maybe 7, 8 different categories of parts are broken, the pyro fuse, the BMC, some fasteners, the sensors, the cooling system, that's it. Not very, very often, the cell breaks. Yes, we also investigate this, and we developed a special solution for one car manufacturers to open the module and even look into the cell, but this is still, I would say, embryonic. That's not really something that's very often. When we look now, you see shortly, you see where are the customer groups. Our customers are on the one side, that's what we see, and now we're coming to what's the business model. Yeah, you see, this is customers, our customers on the one side, the cell manufacturers, clearly, and we have some of them already. also the car manufacturers, and I would say even more the importers here in Germany. Interesting group are the fleet providers, because they get back the car, whether they rented, or the vans that they rented, and then you see they might be damaged. See, there are so far no rules how to investigate this. The recycling companies, and also, you see, car repair shops. Not the smaller ones, but the big dealerships. And on the other side, you see, therefore, we see there several strategic options. See, we started now with the Center of Competence in Hoyerswerda in Saxony, and I'm not from Saxony, you see, but I can say this is a fantastic place. Yeah, you see, where we see a lot of innovations coming. I'm from Aachen, yeah, you see, that's really somewhere else, you see, but you see, I really can say that's an interesting place also with a lot of innovations. And then you see, we see also centralized, and that's the business model, you see where it's going, centralized hubs. Yeah. There will not be so many in each country, yeah, and there will be less, for sure less than we originally all believed, because it takes longer, at least for the next years. Then there will be the decentralized repair shops, who will do some limited repair activities, minor repair, but they can't do a lot of things, especially with the old batteries, because you need investments in climate chambers and other things. And finally, that's maybe for all of us here to think a little bit bigger about partner networks, about the whole stage. That's all, you see, what I can say, see, and I only can finally say, see, European legislation, you see. Will battery repair become more prominent than today, recycling more prominent than other things? Some first signals show this. Another thing is, see, for the line builders here, see, what are automation possibilities? When will it be? You see, but we need more batteries, otherwise nobody will do this. And finally, you see, that's, I would say, a demand for Europe especially. Can we find a solution to increase the repairability of batteries? Americans, we heard this morning, they give investments in subsidies, the Chinese and the line builders, but we here in Europe, we always are, you see, in the circular economy, we are in sustainability for many, many years. Maybe we find together a way to increase the repairability. Thanks.
Christoph, thank you very much. You raised in your presentation a lot of questions also, and I think one, at least that I find very, very interesting, is the battle for batteries. So what would the three of you say? Are you more or less all fishing in the same pond because you would like to have high quality batteries being recycled, being reused, repair, maybe different story, or is it kind of a clear sequence, one after the other, that's going here? Maybe we start with Sven.
It depends. I mean, there's a lot of contractual arrangements that we have to get our batteries back, and so there's usually it's a very organized process.
Yeah. So it depends on the
contract. Not all of a sudden popping up a few batteries out there. So that's
depends on the contract. But how do you secure volume then, Nuria? What is your view?
Ideally, I think that the circular economy defines repair, reuse, and recycle that order, right? So that should be the ideal way the contract should be done. Unfortunately, I'm afraid they were not done like this. As I said, we secure volumes by partnering with the OEMs because they are the owners of the battery at the end and they decide what to do with the batteries. But definitely, I think for the moment, we all fish in the same lake, let's say like this. And this is why, I mean, discussing and understanding, because we probably have different needs at some point. So, and also the value of the battery, as I said, is different, right? I mean, for us, for example, is more relevant the form factor of the battery. Like we can use a lot of different types of batteries inside our system, and I can adapt, I'm not going to say easily, but relatively easily, the BMS to a different chemistry, while I can't adapt my plastic case to a different chemistry, right? So I think this is why we need to establish these value chains. We need to discuss and understand how this volume needs to split.
By the way, establishing value chain, if I may ask one more question to you specifically, what happens to your reused batteries? So how do you make sure that they are being then also recycled? And
we must. We go to contracts. I mean, the extended producer responsibility comes to us, and then we must make sure that we collect those batteries back, and the recycle is at the end, always.
Yeah. Okay.
It doesn't matter what you do, whether you do Second Life or not.
Okay, Christoph, you raised that question about the battle for batteries.
See, we started this in the beginning that we thought about car batteries, but there are much, much more batteries on the market. Yeah? We see this now, heavy construction and off-highway vehicles. See, they are earlier. That's in a stage where you need to repair them. We see this, and now the first thing that we see is in heavy trucks. They have a different way, I'll say. Maybe also they change them, and then maybe they need to be repaired. I'm sure there will also come, then trailers, first caravans, that's now coming on the market. All these have much smaller volume, therefore the need, to find also repairability is maybe more, and for them more important than for a car manufacturer who produces 100,000.
Okay, thank you. Let's jump into the many questions also from the audience. First one is on recycling. Do the same regulations apply to safety testing of the recycled materials as they do to the raw material safety testing, for example, with regard to animal toxicological studies?
Good question. Well, I would assume yes. I mean, because the conditions that you have in your work environment will always be the same, and so the underlying regulation is comparable, no matter whether you take material from one route or the other.
So we can be sure that this has been done, but adds cost, isn't it, then also? Okay. Yeah, let's work through a bit. The next one is on repair. The repair can be useful for module or cells. The main barrier is the liability. Who will insure a repaired battery? This will increase the already high cost of EV insurance. How can this be solved?
This is really a challenge, I see so far. And who will insure a repaired battery? So far, we only repair them, we test them, and we give them, let's say, a stamp that's repaired in accordance, and we always have we as a company, we have a 4I principle. It's not only repaired and, let's say, tested at the end by one person, by two, but it's clear, the liability, it's also later on depending of the usage. If the battery stands for half a year in the winter times outside, full loaded, and then we wait, until springtime, and we try to use it, this is also something, what can happen, and therefore the liability, question mark, who will take over this responsibility, I would say that's open.
Hopefully.
For sure not the service companies. They don't make enough margin on this.
So everything is in flow, and we'll see. It's nice that you have organized your questions according to all three. So Nuria, obviously the next one for you, reuse. How are you preparing for the scenario that new batteries like NA-ion will be highly competitive when compared to second life LFP batteries? You mentioned in the beginning that you are not only competing with other recycled or so, but with the new ones.
Exactly. I mean, our competitors are the new and not the new with the same chemistry that we have in our battery, but the new with the new chemistries popping up every day.
And now, how do you deal with it?
Yeah, sure. So key for us is to reduce, of course, the costs of the remanufacturing, and that's done by standardization, which is a huge challenge. Still, even if we set standard processes today, we still have all the batteries that are already in the market that must be repurposed. This is why we were thinking maybe these batteries split into different flows depending on the chemistry inside. There might be maybe a green premium, right? I mean, our customers, if they have a cheaper battery that it's even new, so they would take the new one. But if we put a price on the sustainability and on the carbon footprint, then maybe we are competitive. So, but this is definitely a huge challenge because, as I said, our competitors are new batteries.
Yeah, okay, good, thank you. Let's just move on. So standardization of batteries makes repair and reuse easier. Where do you see remaining possibilities for differentiation of EU production compared to Asian production? We had that in discussions before, is that now differentiation is the key, but then kind of the other way around is how difficult do the different types of batteries and technologies make your business? So whoever would like to start. Christoph, go ahead.
That's my personal opinion, If everybody, I would say the standardization is already a differentiator. Because if we are able here to standardize this, drive down costs for the use, the total life cycle of a car, and makes it easier for people also later on to buy a used car because they know that standardized, repairable. Yeah? Wheels are today standardized, yeah? And nobody would buy a car, you see, with a wheel that is not standardized. And there are many other things that are standardized in a car, you see, whether you see it or don't see it. I think, you see, car manufacturers, and you see this, how they act and how they market their products, they don't differentiate only by the battery. I think standardization means for us also somehow a little bit of captive market because it's not so easy for somebody else to jump in.
Sven, may I ask you for your view on that question?
Say that again.
on that same question. So on the one hand, we are kind of saying we need differentiation in Europe, but that leads to many different types of batteries, maybe, and technologies, which then in the end makes it maybe more expensive for you to recycle. So how to overcome that dilemma?
As I said, you have either specialized processes for individual chemistries, or you design processes that can intake all of the chemistries. That depends, and there is no one-fits-all solution for the time being. We also need to distinguish between the end-of-life batteries and production scraps. Production waste is the bulk for the next years in terms of recycling activity. Also there, different recycling processes can be established in more direct recycling because the fractions are more discrete, is more clean or more homogenized. While in batteries, the more chemistries evolve, the more complicated it gets, and there will be room for all of us, I think. But there is no one-fits-all solution for the time being.
Okay,
that's for sure.
So some ideas of yours. Nuria, how would you answer that question?
I don't think Europeans are going to be willing to standardize batteries either, because that's the biggest part of IP in the car, and everybody differentiates each other, just not only in the chemistry, on the design, on the thermal conditions, so it's extremely hard, but definitely this is the way to go. Try to make some standards, even in the way you assemble things, and how the tools you need to use to disassemble this. So I think if at some point, and this is why we believe really, let's avoid artificial boundaries. I mean, if we think of the disassembly of the battery when you are designing it, that would be probably the way to go, and is where we could do better. So you still inside, let's say, have your IP, but you make much easier to disassemble that battery. And automation, of course, we were speaking about automation, AI, so AI tools that help you understand how to disassemble that battery. All this is going to drive the industry, and we come back again, like this morning, right? Equipment manufacturers, innovation, etc.
And I mean, automation, I think, is a good point. How much automation is possible in your businesses to drive the business
today?
Further?
I would say in the let's say in the repair and also the disassembly, it's still, I would say, a long way to go. Yeah, and when we talk about, you see, why? Because the volume is not high enough for that a line builder really develops a solution for an automated solution. No way about it. See, therefore, you see, as soon as this ramps up, this might become interesting. But today, and that's what we see, how the processes are different, it's still manual work.
Every screw in the battery is different.
Correct.
You need a different tool for not every screw, but only this. I mean, it sounds really stupid, but it takes so much time to change your tooling for every. So automation, it's a huge barrier. This kind of even lag in the screws.
Yeah, that's where the regulation, the battery regulation, will be helpful, and the battery passport with dismantling manuals.
Exactly.
Because today you need to investigate first what you get back, and then you design or you develop your own dismantling manuals for each and every different battery. If that comes along with the battery, it will have the effect that it can be more effectively recycled, if not automated, if these data will be machine readable. At the same time, it also forces the manufacturers to reflect in their design phase about end of life, which so far has not really been the case. You produce something and end of story, and that will change with the request for having this mantling manuals as part of a data point in a battery passport.
Good, thank you much. We are almost at the end already. Maybe one last question, please, a very short answer, if you may, starting with you, Christoph, going the line. If you take a look into the future, and look at kind of the market for battery-related services, what we are talking here about. What is your, let's say, short-term vision, if that's not a contradiction? How long will it take? What kind of timelines are we talking about until we see really a take-up of those markets and profitable businesses at large?
If we look, you see, to the growth of the business and let's say the penetration on the market, the forecast is 2030, 50 million, maybe now it realistically 8 or 9, you see, that's the latest, what I heard today even, and that's what the VDA is saying, the German Association. Then you see, overall, you see, it takes 10 years. But once again, only car. Much faster, I'm sure, much faster outside of automotive, construction vehicles and other markets, that's what I said.
Okay, thank you. Sven, your outlook.
Yeah, I would agree. I mean,
agree. Thank you. That's a short answer. Thank you very much. And Nuria, last words for you.
Yeah, I mean, it's, these crystal ball questions is always very difficult to answer.
Yeah.
I think he.
Yeah, I appreciate it. Your short answer.
Reasonable.
Yeah, I think battery passport or battery regulation in general has a huge thing to do here in at least trying to move the industry towards one direction. I don't know what will come out of that and how far we will go, but I think it's an eye-opening exercise, and that's already good enough, probably.